that's me. Don't worry about me. I'm here regardless. And what are we going to cover? We're going to cover vehicle steering, do a little overview, system component descriptions, regulatory requirements, best practices. And that's a lot to put in an hour. And I'm going to tell you, just like I do with all my lunch and learns, to be honest with you, we're just not going to please everybody and cover everybody. And those of you that work on this stuff, by all means, you know, you're going to feel the pain in some of the slides. You know what I'm talking about. If you're new to this, if this is your first exposure to this area, hopefully we can steer you in the right direction. So I try to make everything, you know, kind of fits all. So, and including myself, I need little reminders once in a while when I work on these vehicles too, you know, so no different than you guys. But steering, the system that we're going to talk about, it is really a very important safety component of a vehicle, and it really truly is. I can't emphasize it enough. And there's a lot of components that are involved with steering, starting with the steering wheel, of course. I walked around with it, and ending at the road wheel, you know. Not to mention a nut behind the steering wheel too. So, but anyway, the purpose steering system, we can't control the nut behind the wheel. So, but back to this, the purpose of steering system is to give the operator directional control of the vehicle. You know, we're trying to have stability here. But because of the safety aspect, this system and its components, they definitely fall under federal regulations, not only in the Federal Motor Carrier Safety Regulations, but there's a lot involved too with the Federal Motor Vehicle Safety Standards. So, you know, so when a problem or complaint from a driver occurs, it's up to us to diagnose the system to figure out what the cause is, you know. And where do we use this steering? Because we're into heavy duty, you know. In commercial vehicles with weights often exceeding 40 tons of combined vehicle and cargo weight, you know, and that guy that's behind the wheel, he wants precise directional control. Okay? So ideally, the system must perform this with little driver effort. Okay, it ain't like back in '46 when I first started driving. You had the manual, and that's when men were men. Just kidding, guys. You know, but you know, you want all the creature comforts. I mean, you don't want to tire out the driver. So most truck steering systems are power steering type, and that's why instead of the old manual type, you know, steering system is also closely related to the front suspension, axle, wheel, tire components. So there's a relationship. It's a marriage. Improper steering adjustment or problems can lead to alignment and tire wear problems. It's a marriage again. They have to work together. And at the same time, suspension, axle, and wheel problems, all of those can affect steering and handling. Okay? And this is, I just made one kind of a stick in your face slide. Again, steering is the one area I personally, in my shop, us guys, we never take a chance at it. I don't take any shortcuts. Any problems I find get documented and it gets thrown into the customer's lap. If you lose brakes and steering, you definitely are screwed. And that's a conversation Robert McElroy and we're having the other day on this, you know. But these are typical components that tend to be the high maintenance items. That's us guys, okay? And typically, it's the maintenance that does create some problem. Don't get me wrong, components will always wear, but proper maintenance and PMs, it's so important to prevent this early failures. Okay, and this picture here, I got it from Dayton. Dayton has pretty near every part that you can think of for heavy duty trucks. I mean, they got it broke up, so on occasion you're going to see Dayton in here because not trying to sell Dayton parts, but it's very convenient for me as a trainer. The easiest access I can get and the more I can portray out there, and you know, working with Dorman and Dayton, you know, I really appreciate just, you know, looking at the technical aspect that they can provide. Go for it. Previous picture had the kingpin, and guess what? This is what we're trying to prevent here, okay? And the reason I'm showing you this, a lot of places when they do a PM and stuff, they don't necessarily raise up the wheel, the axle I should say, and do this. Tends to be a kind of a process where most of the time a lot of companies tend to leave the wheels on the ground. And in my shop, I guess I'm trying to not tell anybody how to do things, but most certainly in my shop, no matter what, if it comes in for oil change, inspection, whatever, those wheels get jacked off the ground. You know, we don't take no chances. So here is, and you might not see this too well, but what happens is, I hope I can get the zoom in over here. Right? So again, walks you through the function. And again, you're going to have these handouts. So if we don't have every little word we're going to discuss, you know, it's okay. Right? You have the handouts, features and benefits. Okay. Right here it says the kingpin is the very heart of the axle assembly. Mandatory for a replacement part of this nature to be the highest quality and so on. There are quite a few different bushing types, and those of you have that worked on these, you know exactly what I'm talking about. You got the nylon type, provide reduced steering effort. You know, generally only recommended for vehicles which spend most of their time on highways. They tend to wear out faster. And it's a good description. And of course, you got the steel back bronze ones. We've had them forever and ever. You know, if you don't have reamers, don't get involved with them. You know, and here's the next page, composite bushings. They incorporate a steel backing as with the bronze bushing, and then I get the needle bearing type, and of course a so-called no ream bimetals and a spiral no ream. So a lot of you probably have gotten involved with the various types of bushings, you know, throughout the years that you've had to work with, you know. Now, let's get into the real world here. You know, to be honest with you, this is my world. This is your world, okay? And I put on there, is today your lucky day? Lucky day is this one over here. Look how nice the lube has gotten in there. This is a type of day you'd give a little whack with a hammer and your pin falls right out of there. This, not a lucky day, okay? Time to get your best tool out. You can see the rust and everything in there. And those of you that work on this or had to replace them once or twice, or if you do it all the time, you know exactly what I'm talking about. You are definitely going to bust your, you know what, off trying to get them out. You know, it'd probably take two guys, somebody with a torch and so on. Eh? But again, going on with there, it's not the easiest job. There's a lot to it. You know, you're trying to get your drum off and everything else. And, you know, of course, everything's been on forever, ever. And you're trying to knock off the drag links and, of course, the tie rod ends, you know. And hopefully, you can see over here on this side here, this is a lucky one. A little tap with a hammer and a little bit of a big punch and out it comes, you know. And of course, I mentioned reaming. The reaming is kind of it is a skill set. I'll be very honest with you. It's not for everybody. You kind of really have to do quite a few of them, and you know, you just don't go in there and start reaming and knocking off and just putting the pin on. It's like there's such a thing as knocking too much off, and guess what that pin's going to be? It's going to be wobbling all over. Now what? You're going to get a new set of bushings. Try to get bushings without a kit. You know, it's virtually impossible. So this is a little bit of a time consuming, and you need to take pride in it, and you need to get that beautiful, beautiful fit in there. Make sure that your reamers, everything is sharp, you know. These are the new components that must be installed, key components. Eh? And if you look over here, I want to do something here, and it is kind of important. You see this? My question is, how much do you know about these seals? Okay. I'm going to do something on the board, but I want to make sure. Let me see if I can do this. If you look over here, and I'll try to zoom in a little better on my other camera here. this is a perfect example. Let me move this other way. Everybody knows a seal, okay? You have them in your wheels. You have them all over the place, okay? So you have, for lack of better explanation, you have an oil side and a air side. So if this was a hub underneath here, typically where my hand is are the bearings and stuff, you would put this in this way, okay? You wouldn't put it in this way, right? How about the kingpins? How would you put that in? So I'm going to do something on the board. I pre-drew something here. You're going to have to go over here. And this is something you got it? This is something I do on in my brake classes, and I'll walk over there real fast. So that seal I showed you over there, so pretend that's your inner lip in here, okay? And I always ask the brake classes, like, you're doing a brake cam, because it's easier for me to show with a brake cam, but you can pretend this is your kingpin going in, flip it around, okay? But the concept is the same. So I always ask, how do you put the seal in? Okay, you can have a bushings in here, whatever. Do you put it in like A, B, A, B? And this is where somebody said that it'd be so nice to have voice and we can discuss that, because I'd be interested to see how anybody would put it in. To tell you the truth, you know, if you want to shoot, you know, A or B on the chat box, knock yourselves out, go for it. But what happens is, to save us a little bit of the time, okay, just think about this. In this particular case, okay, if you were working on a cam, and they're similar to the seals you got, the way you want to put it is A on this side here, okay, where your actual cam. This is a slack adjuster, guys. I paid a lot of money to go through an art class, so don't knock me too much here. So this is the way you want it on this side, and this is the way you want it on this side, and this is the slack side. This is the way you want it there. So what I do is I ask everybody, well, what are you trying to do when you're trying to grease? And that opens up a good conversation too, because everybody says, you know, kind of reduce friction and everything so nothing binds, and you are correct on all that stuff too. But just think of the environment these things are in. When I grease and I shoot grease in here, the biggest thing in this particular application is I'm also trying to purge. So if I shoot grease in here, like this, it's going to hit the seal here, just the way you would put your wheel seal on, and it's going to tighten up against the seal, just like you would have in your wheel cylinders and master cylinders. You don't want anything leaking by. However, we are purging. We want to get the crap out. So if we put the seal, in your mind would be opposite, that gives us a provision to purge all the crap out of here. And you know what? If this grease goes by the spline here, so what? It's even better. So let's think about this. Let's flip this out. Okay, so if this was your kingpin over here, this is your spindle. I'll try to put it over here, you know. So you have your bushing on top here. You got the grease fitting in here. And the grease fitting could be on top. You guys have seen it all over. So your pin is going to come in down through here, okay? This is where I'm talking about is you need to put it in what in your mind is backwards, okay? So when you grease this thing and you shoot grease in here, you allow the grease to escape here. I mean, you can thoroughly grease it. You see the grease come out here. Because once in a while, you're going to run across a truck, okay? You're doing a PM and you're going to grease this thing and it's not taking grease. It's hitting a freaking wall. If this is a cap, grease might want to come out over here. You might want to put another gasket, do whatever. And then you look at this, like, I do not understand what's going on because it doesn't look like this thing is too old. Chances are pretty good. You know, it's not that this is binding here. Somebody didn't ream it correctly. If you didn't ream it correctly, you're going to be either loose, or it's going to be so tight you're going to be binding. Chances are pretty good somebody did not put this seal in correctly. So you can, and a lot of shops, a lot of guys have done it. Well, maybe if I put some heat here, maybe something's rusted, frozen. But I wanted to point this out. Yes, there is a difference in the way, you put those seals in. So hopefully that's a thing you can, that, you know what? That's a good way of doing it. I see that Mo, and that really is, if you got the equivalency of a press and everything else, we have a lot of, it's a competitive world out there. This is something, if you have your own fleet all day long, I would do it. But we have a group of people out there that they'll go around to different shops and they're like, how much is it going to cost? And then you can, kind of walk yourself out of the ballpark, So, but that's a very good idea if you can, and I use, even with the axle in, to be honest with you, I'll use jacks and presses, whatever it takes, to get those things out, and you're right, but the industry practice I pointed out is that it seems like everybody out there, again, they will wind up using heat and stuff. And I've never had anybody ever say that, something has it's been a result and something has gone wrong because of that practice. But nope, I have absolutely all day long the torches, and if you can avoid heat, absolutely. Oops, I need to get back on this. So everything fit together, no binding, and it took grease. Okay? Now, this is nothing new, this tapered kingpins that used on Max and Volvos, So if you go on Dorman's site, they got a lot of repair kits and stuff. They actually have some really nice instructions. And Mac, when I first started, in the bottom, they had a kind of adjusting with looked like almost like a bunch of screw slots on the bottom. And instead of, if you start to wear a little, you had the opportunity to turn this in and it would tighten everything up. And it was a nice concept, it worked pretty good on that, But kingpins aren't the only components in there. You also have to contend with, I mentioned already, the drag links and tie rod ends. And those are things you want to definitely look at, because we are in commercial motor. We are in a commercial motor vehicle industry. And what happens, and I'll get to that here in a minute, okay? I want to throw that in case you didn't see that. Check this out. There's a missing bearing over here, But I'm still trying to concentrate on this over here. Just wanted to see how observant everybody is. Eh? We're into tie rods, and if you can see that...
Can you shake the steering wheel again?
My point being is, these vehicles are meant to get preams. They're meant to get inspections. And I'm thinking a lot of times, a lot of stuff isn't getting caught. And I'll get back to that in a second too. But the tie rod ends, they are very, very important. Again, what's the function? Connect the tie rod arms of the spindles to transfer steering force. Ball and socket type of joints. They, take my word for it, with our vocation, they really have to withstand a lot of punishment. So even those come in all sorts of different varieties. If you can't see it too good up there, it's seal designs. You got the sliding seal, it's the most common type. Then you have a boot seal, it's always used in permanently lubricated sockets, okay, inspection procedures, permanent lubricated sockets. I remember, with the pickup trucks when Ford went into greaseless, you don't grease anything. Boy, shortly within a short time, never saw such a high failure rate of components, ball joints and tie rods and stuff. So I'm not quite sure where the wisdom is with all that stuff, And of course, there's wear limits to all of this. And this is where I was heading. if we don't take care of it and it slips through the cracks, it's going to get pulled over one of these days on a roadside inspection, because that's part of our business. And if you look over here, axle 1 left side rod ball socket loose exceeding 1/8 up and down movement measured with hand pressure only. Okay, so those guys are out there. We don't check it, they'll check it. Take my word for it. All the components of a truck's front axle, steering, suspension, they are aligned by the vehicle manufacturers. And why? Again, to balance the forces created by centrifugal force, momentum while the vehicle is in motion, gravity and friction. When properly aligned, the wheels of a loaded vehicle will contact the road correctly, allowing the wheels to roll without dragging, scuffing, or slipping on the road. Benefits of a properly aligned vehicle are longer tire life, directional stability, better fuel economy, less steering, less wear on front end parts. Primary alignment angles adjustments are toe, caster, camber, turning angle, kingpin, inclination. Somebody already meant acronym geometry. Also axle alignment, because it can affect tire wear and steering characteristics. Don't bother with an alignment unless you check all the components first. To be very honest with you, chances are pretty good. If you got an alignment issue, you're definitely going to wind up having some components, tie rod ends and so on, that are not functioning the way they should. They're worn or whatever the case may be. Don't forget tire pressures, ride height, and so on. Now, this particular thing, next few slides, I got years ago from Hunter. I talked with Hunter. They gave me okay to use it. They've been in the alignment business forever. I'm not doing a total alignment, caster camber, but one of the most important ones that we always tend to get into is toe settings. Purpose of toe is to allow the tire to run straight during normal operating conditions. Deviation from this condition can result in either toe in or positive toe, toe out and negative toe. There's a nice picture of it. Okay, toe in, positive toe. You want just a little bit. Positive toe is necessary for improved tread life, but however, what's a little bit? Toe out, negative. That definitely will accelerate tread wear. Wear characteristics due to excessive toe. Excessive toe, positive toe, they will result in outside edge wear of the tire. I mentioned, I think when I did the tire thing, looking at tires, you're investigating, it's a good indicator of issues that you have. So you put 2 and 2 together. Excessive toe out, your negative toe, results in inside edge wear of the tire. Most of the time, steering axle toe is adjustable, providing your tube is free and it can move, and so on and so on. Normally adjusted. Again, I guess I want to mention that I'm flipping back because when you see the slides, everything seems to be straightforward. I forgot to turn my phone off. Sorry about that. Damn it. But drive axle toe, trailer axle toe are not normally adjusted. Back to this adjusting the toe. Again, if the tube, those threads are frozen, you're going to have issues again. A lot of times you're going to wind up getting the whole tube and both tie rod ends and so on and so on. But specifications. So where would you get your information for the specs? Chassis OEMs, axle OEMs, tire OEMs, alignment equipment OEMs. They're very good for that information. Okay, local alignment shops. There's places that do nothing but specialize in alignments. But if you're the one that just once in a while gets into it, okay, here are your targets: total toe 16 inch, okay, camber less than a quarter, caster, left, right, you know, and you got a little bit of a setback. But again, you always RTFI. You want to get into the specific specifications, you know, get to wherever you can get your information, but this will give you a general ballpark over here. Okay? I'm just looking at that, you know, lip of the seal. Yeah, if actually, you know, I had a young man, young guy, really nice guy a few years ago. We hired him, and I asked him, have you ever done kingpin jobs? Because again, I mentioned too, you know, it's a hard job getting the kingpins out and everything else. And the reaming part can be, you know, it's a skill set you have to learn. So he says, sure have, you know. So he finished a kingpin job, and he came up to me. He says, I have a little bit of issue. Now this is a brand new, changed kingpin and, you know, bushings and the bearing and everything else, shimmed it up correctly and stuff. And he came back and he says, hey, Swede, I think we have a problem. I might have reamed it a little too bad, because every time I put the grease on this thing, every time I put grease on it, it keeps popping grease out of the top. I tried, you know, regasketing, doing all sorts of stuff. So I told him, I says, do me a favor, humor me. I says, because if we're going to do something, now's the time. Everything's clean and fresh. I says, get the kingpin out of there for me and call me over when you got it. And immediately I showed him that seal was on backwards, and that's your whole problem over there, you know. And that's, like I said, I've run across this, and I'm sure a lot of you guys have too. You know, somebody brings in a vehicle, it doesn't take grease, and it's like, man, it ain't taking grease and stuff. You know, and chances are pretty good, and that might not be the only reason, but chances might be pretty good that seal is, you know, kind of upside down. Somebody didn't think about the application, and that's why I used that board over there. The same thing applies with the camshafts, you know. So, yeah. But back to this. So we're going to get into the steering portion of the other Porsche side of it. Eh? Some heavy vehicles, I just threw that in, you know, so you guys that work on these huge heavy vocation type of vehicles, you know, don't be surprised. One of these vehicles might come in and you have a steering box on both sides, you know. So, you know, all sorts of configurations are out there. And all day long, this picture over here, you'll see some grease and oil coming out. That's one of the most common issues you probably might run across: leaking seals, fittings, hoses. Okay? And, you know, on the roadside, all day long, visually, you see something like that. That's such an easy hit. That's such a easy hit, you know, in steering. It's a violation, staring you in the face all day long, and that means points in CSA and so on. Here's another one. Sector shaft, pitman arm, it's loose, and that will put you out of service, believe it or not. And all it took on top over there, most of the time, you tighten that bolt a little more, squeeze it in, and it's tight as can be. I've gone on service calls. Minute I know this is a violation, I'll go there with some big sockets, wrenches, tighten it up, and officer say, okay, shake it again, good to go. You know. My point being is, but do we look for those kind of things? I would never let something like this go, because again, look at the pinch point over there. I mean, if that ever comes off, you got some issues. Eh? Power steering, truck's power steering is identical to the manual steering in many ways, okay, because you're still going to use the same steer axle components and linkages. The difference is going to be the addition of a hydraulic system. Pump is used to deliver hydraulic fluid under pressure to a power steering gear. Gearbox incorporates hydraulic valve and passages that allow the hydraulic pressure assist in turning the wheel. I'm going to try to keep it simple, and if you approached a vehicle, it's what you typically would see. You'd see over here my little hydraulic pump, you got a pressure line, supply line, return lines, and chances are pretty good the return lines are going to go through some kind of a cooler, because temperature control for steering fluid is huge. Okay? This is from Dayton. They did a pretty nice job. Give you some explanation. You know, you got some arrows pointing to it. You got the pressure return ports. You got a relief valve, auxiliary port. Okay, you see the auxiliary port. Some gears are equipped with 4 lines, provide hydraulic assist from the master gear to an auxiliary gear mounted on the opposite frame rail. Remember that picture previously? So again, provisions are there. Okay. There are, guys, and I've had to rebuild these. That's why you see the parts there. But as a rule, I'll be very honest with you. If I have an issue with a steering gear, okay, with that box, chances are pretty good. I'm not going to mess around. I'm just going to get a box and, you know, deal with it, put a new one on, and usually get a pretty good warranty comes with it and stuff. So, you know. The power steering pump, again, now this is not the gearbox. This is the pump. And it's used to develop the hydraulic flow needed to provide the power assist to the steering gear. Can be gear driven or belt driven depending on the truck and what size of truck. There's 2 basic types used on heavy trucks. They're the vane or roller. Some vehicles are equipped with gear or rotary pumps. Hydraulic fluid used in the pump could be stored either in a remotely mounted reservoir, okay, or an integral part of the pump assembly. Fluid is usually routed between the reservoir and pump, and between the pump and the steering gear via hoses and lines. And of course, well, we'll get into relief valve a little bit. You could develop excessive pressure, and to overcome that so we don't have those excessive pressures, you're going to wind up having a relief valve in there. Now, this is a very important concept. Pumps do not pump pressure. And this is with all hydraulic systems. I mean, you might have packers and so on using cylinders and so on. You know, the pressure within a hydraulic system is caused by the resistance to flow. So you got all the components of the hydraulic system are affected by flow and pressure. You know, they have to work together. It's a design feature. You got to adhere to OEM specs, and I'll get into specs a little bit here. Both pressure and flow are required to accomplish work. We all know about atmospheric pressure, so I'm trying to keep it stupidly simple. It's a little bit more involved, but if you want to look at that, atmospheric pressure is the force which sends oil to the pump typically. But then we're going to have to concern ourselves with their working pressure. That's the pressure which occurs when the system is under a load. Again, you got a restriction, you got a load. Okay? And we talked about the relief pressure occurs when the oil is passed over the relief valve used to protect the system. You know, and it only makes sense. Relieve pressure. I got too much pressure. We got to relieve it, you know. And of course, we got oil that's used to lubricate all the components. And we often forget about the concept of having oil in a system. Okay, we're back to the same thing. Oh yeah, lubrication. It's a medium that we utilize to do this and that. But don't forget, it's also meant to dissipate heat and carry away any contaminants so they can be removed by filtering. So I put a little note there. Oil temperature contamination are typically the cause of steering system hydraulic failures. So we're back to maintenance. Okay. And this is what a typical pump would look like, okay? And this is a Vickers, you know, nice little shot from Dayton over here, you know, the breakdown of it, you know, and just trying to point out a few things, you know. It's not big compared to what the pump is, but just so you know, okay, and I'm using Vickers as an example over here, okay. Now, there's TRW power steering pumps, okay. In a TRW, if I remember correctly, the relief settings will be the 5th and 6th number in the pump part number. But if you have those numbers, and I put it out there, it kind of helps you out that if you're trying to do any checking of the system or trying to, make sure the relief valve is, working the way it should, you can see just by the letters, you can kind of make sense of, what you're looking for, So you got the pressure settings, you got the flow rate and everything. So the manufacturers do a real good job of that kind of stuff, Now, you're going to occasionally have to test. You're going to have to make a decision. And everybody I find out there has their own way of doing it. So I want to be a little bit more accurate. So I follow the OEM type of recommendations here. Okay. So if you suspect a problem with the power steering system, test the hydraulic supply system first. Absolutely. Proper power steering requires adequate supply of oil pressure and oil flow. Okay. And this is where you have to get into some information, check for specs. Okay. So high system oil temperatures reduce efficiency. We talked about temperature, so that's important. Okay. Most high temperature definitely caused by restriction to flow or inadequate system oil capacity to allow for heat dissipation. Again, so make sure those reservoirs are filled. Let's keep it stupidly simple. A supply pump that constantly operates at maximum pressure relief will also generate more heat than can be dissipated, So that setting is important. Pressure gauges and flow meters are used to diagnose power steering problems, and those same meters are used to basically diagnose any kind of a hydraulic system, whether you're trying to work with cylinders or whatever. But in this particular case, you want to make sure that you got gauges that are 3,000 psi. Flow meter should be capable of reading 10 grams per minute. And of course, you want to have a shut-off valve downstream from the pressure gauge that's used to isolate the steering pump from the steering gear. Closing the valve allows you to read the maximum pump, and then get a thermometer in the reservoir that's going to indicate system pressures. And, those things can get pricey, but I'm just going to point out a few things here. Throughout the years, I've got a box full of gauges. I got all sorts of different hoses and adapters, and this is what I'm talking about, shut things off and so on, shut off valves. So most of the stuff, depending on how much you get into steering, a lot of fleets, they'll get it into just once in a while, deadhead pressure tests over here. I see Chino. Okay. Most of you guys in the shops, you slowly but surely, as you get in more and more of this type of work, you're gonna wind up accumulating, different size hoses and so on. So that tends to, this is a sample, but that tends to be the way us guys seem to operate. So make our life easier. Following is a general procedure. Make all necessary gauge meter connections. Start the engine to check system oil level and flow through the flow meter. Place the thermometer in the reservoir to monitor oil temperature. With the engine at idle, steer from lock to lock several times to allow the system warm up. Okay, and keep that thought in mind. I said deadheading over there, that deadhead pressure. I'm going to get to that in a second here. Okay, that is it's a concept, but we can do some damage too. So I think I have it in a couple of slides here, And usually deadhead means you're going all the way to the extreme and you hit the stops, and that's not really what you want to do, because the stop adjustments are vary and they play an important role in this. But anyway, engine idle, steer from lock to lock several times at the specified idle speed. Slowly turn the shutoff valve until closed and read the pressure open shutoff valve as quickly as possible. Okay, flow must not fall below the minimum grams per minute flow specified. So I'll get back to that. Let me see what else we get. Increase the speed to 1500 RPM. Note the flow rate with the steering wheel stationary. Compare this reading to the maximum specified flow. Excessive oil flow rate can cause high operating temperature and sluggish heavy steering. And again, oil temperature is best checked after a couple hours of normal operation. So you want to make sure that somehow you keep that temperature in check. All these tests should be performed with a load on the front axle, and that's very important to duplicate the real world conditions. Okay? And I think that thing with a end-to-end, I'm going to have it in a poppet valves. Steering complaints usually start with the driver, so the best place to start is communicating with the driver. Ask questions like what, when, where, and how. So you duplicate the problem so you can feel or see it. A good visual is a must of the whole truck to eliminate or discover the obvious. Not all steering problems are, for example, the steering gearbox. You want to always think out of the box. Tires, frozen components, alignments, and so on and so on. Most component manufacturers have nice flow charts for diagnostics that address common complaints such as hard steering, binding, darting, oversteer, road wander, loose steering, shimmy, and so on. So you have quite a few of complaints that these drivers can come up with when they're going up and down the road. So you pretty near have to, figure out which direction am I going. So the following common complaints or problems related. And I kind of like bolded them a little bit more. Hard steering, binding, oversteer, loose steering, road wander, shimmy, noises, external leak, directional pull. And the reason I slowed this down here is when the driver complains about this stuff, me personally, I want to duplicate it. I want to take that vehicle out and I want to actually feel this thing. So if I make any repairs, I know I definitely made a change to it. Okay?
Go for it.
And once in a while you get a problem that's out of the box. There is no driver in this cabin there. There's nobody sitting there. Okay? And if you look over here, this thing's steering pretty near by itself, okay? I included a little bit of, do this troubleshooting guide, okay? So if you guys ever get the Dayton catalogs, they'll have a lot of nice information in there, on the hard turning and so on, okay? And like I said, we don't have time to go through every little item here. This is basically an overview. Now, flushing. That's required whenever a power steering pump gear reservoir is replaced. Important concept, flush the old oil from the system, replace it with new. We started this thing with power steering, oil, clean all day long, okay? And if you have a failure in one of the gearboxes or the pump or anything, I tell you all day long, you're gonna have metals in there, all sorts of stuff. You need to get it out of there. If you replace a pump, make sure you get everything out of it. If you replace a gearbox, make sure you flush it before you let that vehicle go. And typical procedure, lift front axle off the ground, supported stance, do not connect pressure return hoses, place pressure hose in a clean container, and of course, make sure you get the proper fluid, absolutely all day long. You got most of these systems, they're specific because you do have a few choices depending on who the manufacturer is. You're going to wind up using twice the amount of fluid, which makes sense. It's the capacity of the entire system. Having a system ready to crank the engine, preferably, if you can disconnect it or not, but most of the time you can't. So somebody needs to be up there that you can crank it and then you can shut it off. If you can prevent starting, that's even better. But, just get whatever it takes to get that oil out of there. Now, to your thing with the deadheading and stuff. Avoid hitting or holding against the stop when turning the wheel. Maintain fluid level throughout flushing process. Flush until clean fluid is coming out of hose. Remove return hose from reservoir, clean and dry, air blowing, of course. And then again, after reinstalling hose, fill the reservoir, crank engine for 5 seconds, turn the steering wheel stop to stop without cranking engine, top off reservoir oil. And again, turn engine stop to stop approximately 6 times. Okay? Avoid holding against the axle stops. I'm going to tell you right now, I cannot, and most places do that. I want my extreme, so I'm going to go and, you know, hit the stops. And if you, and I didn't put it in here, a lot of the RTFIs, they tell you to use a little block of wood. I believe it's like a whatever, not like a shim, and put that between the stop and, you know, when you start turning the wheel, so you don't go to that extreme. You know, it's one of those things that, you know, a lot of us don't think about. Now here's the steering gear and pump installation instruction. Disconnect the line, plug the reservoir port, fill the reservoir with recommended, and I'm going to rush now. Disconnect ignition if possible. Jack the front wheels off. Crank starter motor, and similar to what you're trying to do with the flushing. Unplug reservoir return port. Reconnect return line. Replace contaminated oil filter all day long. The filter. Fill the reservoir capacity. Start engine. Run for 30 seconds. Shut engine off. And I'm hoping, like I said, I'm going awful fast, but the nice thing about handouts is slow it down. Don't throw those handouts out. Print them out, use them, do whatever, and use them as a guide, you know. And again, we're still into flushing, and again, that's another recommended procedure. Fill or refill the pump reservoir to the coal mark, or just enough to cover the internal filter. Start the engine, let run at idle speed, couple minutes. Cycle the steering wheel a few times, eliminate entrapped air. For pumps that have a dipstick, showing hot full only, allow the truck to reach operating temperature before stopping engines. For units with coal fill, marks the engine may be stopped after cycling. And of course, don't forget to fill the indicated level. Right? RTFI, read the specific manufacturer's recommendations. All right. Initial poppet setting, okay? This procedure is for new and remanufactured steering gears. Okay, this is from Dayton. System must be flushed. We went through the flushing stuff, okay? Now what you want to do is inspect axle stop bolts to ensure they are set to vehicle manufacturers. I can't emphasize that enough, okay? Check the front end up, start the engine, let it idle. Turn steering wheel to full left until you contact axle stops. Pull hard on the wheel. Do not hold against the axle stop for more than 5 seconds. Now turn full right until you contact axle stops. Pull hard on the steering wheel. Do not hold against the axle stop for more than 5 seconds. Turn the vehicle off. Okay. Now this is a poppet adjustment. The previous slide was a procedure for doing an automatic poppet adjustment. The concept is to ensure that the relief plunger is capable of reducing steering pressure when the wheels have reached their limits of turn. This prevents the supply pump from operating a maximum relief pressure when the road wheels are at the steering limit, when they finally do hit the stops. For all this to occur, the timing marks on the steering shaft are 90 degrees from the center line, properly aligned with the mark on the pitman arm. Make sure the pitman arm positioning allows for the center point of the sector shaft. So with the wheels square to frame, check the drag link for proper adjustment and install. Okay. And again, it's a continuation. It's in your handouts. After flushing procedure that we had in the previous, do the following for a manual poppet. If you have to do a manual poppet adjustment, with the full weight of the vehicle on all wheels, turn the steering wheel in one direction until a high pressure hiss is, or the axle stops make contact. Basically, you're hearing for a high pressure hiss. Turn the relief plunger located on both ends of the gear in or out until the high pressure hiss is heard when there is 1/8 to 3/16 inch clearance between the axle stops. And this is what I was talking about. If you notice in all these slides, you are going to try to avoid hitting the axle stops. And this is per TRW, Shepherd, and so on, a few others. Okay? Bleeding air. You know, and you'll find similar procedures. Okay, if this is a replacement steering gearbox, follow the poppet plunger adjustment procedure. Okay, then you're going to follow the steps. Start the engine, let it idle, do not turn steering wheel, shut off engine, check the reservoir, refill, start the engine, and so on and so on. Okay? Basically, you're trying to remove all the air from the steering system. Okay? And follow those procedures. Do not turn steering wheel with manual bleed screw loosened. Diagnosing, start simple. Okay? Start with the tire pressures, especially with the steer axle. In combination use, boy, that drive fifth wheel, that coupler, that can be a hindrance because you want everything working. So you don't want to have that effort on that steering. You don't want that to fight you. Binding. A lot of guys don't think about this. Disconnect the drag link or pitman arm. Do not steer the gear with linkage removed. The reason is you want to prevent misadjustment of the poppets that we were talking about before. With wheels off the ground, pull and push tire from axle stop to axle stop. Tire should move because now you're going all the way, okay? You're basically looking for any kind of a binding issue, kingpins, and so on. You could wind up having a steering column binding. Again, wheels off ground, slowly steer vehicle until you feel that binding at that moment in time. Move the U-joints and or column to find the problem. Okay? And frozen telescopic shafts, when that vehicle turns, one side wants to rise a little, one wants to lower, and that telescope is meant to move with it. But if it doesn't move because nobody ever bothered to see lubricated and so on, you will definitely have a binding. It might not even return properly. Air in hydraulic system, inspect reservoir for air bubbles, foaming. If foaming, look for cracks, loose fittings. Look for oil level changes between the engine off, engine on cycles. So if the fluid levels increases when the vehicle shut off, chances are pretty good you're going to have an air pocket trapped in the steering gear. In this case, again, go back to the bleed the steering gear, that process. And again, repeat that process 3 times, recheck the oil, okay? Mechanical checks. We already discussed about the axle stop setting. Check to make sure axle stops are set to manufacturer specs. Pitman arm and output shaft alignment. Make sure the timing marks are aligned. Make sure the right mark is used. Some pitman arms have more than one mark, and I'll hold it in my hand here. I'll get one right here. This is what you're looking at over here, and believe it or not, you might have 2 marks over here. And usually if I get into stuff like this, if I can't see the marks real good, and if nobody ever complained about this, okay, about this being an issue here, before I take it off, I'll take my chisel and I'll make sure that if I have to put this back on, I'll know exactly when on the way it came off, This, by the way, was from an accident. It totally sheared. That's why this is a nice little, unit for me to hold in my hand. We're almost there. I'm looking by the slides. So again, misadjusted drag length must be correct. Check the length after timing marks aligned and gear is at its center position and the road wheels are straight ahead. Steering lash. Okay, this would be a 2-person task. One person turns steering wheel back and forth 1 corner each way. Second person checks for looseness, excessive movement in components, areas. And I emphasize anything to do with steering. And it doesn't matter what it is. U-bolts, spring bushings, pins, hangers, brackets, shackles, wheel bearings, lug nuts. Don't forget binding brakes, okay? And that part of it should be part of any preventive maintenance or inspection task. Okay? Repair mistakes to avoid. Disconnecting the drag link from the spindle. Then rotating the steering gear to get the pitman arm out of the way if you want to work on a nearby component for whatever reason. In the above case, make sure to disconnect the pitman arm from the steering gear instead and don't rotate the steering gear. Okay? You don't want to be manually, taking a chance, mispositioning the poppets and all that stuff. Reposition the steering wheel to center after replacing tie rod end or ends of the drag link. Any mistakes we make can lead to steering gear leaks and also result in driver complaints of hard steering, uneven effort, and so on. Okay. So we have a thing for questions here, It all depends. I see that, you know, it all depends on the manufacturer of this. Had to do this pop-it adjustment on a new vehicle, would not turn full to the right. Those are I got to tell you, and all day long, those are the issues you're going to wind up getting into, and those are frustrating issues. You know, then all of a sudden, you know, not knowing what make, whose make, you know, gearbox it is or whatever. There's a perfect example that you're going to have to get into, you know, into the specs and everything else. I'm trying to look at all that stuff. Free play on steering wheel. Matter of fact, I just rechecked one with the free play on the. I'm thinking you're talking about the steering wheel itself. I actually put that in one of my PowerPoints. You know, because nobody thinks about it, but if you're the guy doing the inspection in there, and all of a sudden I'm the one that was up there, and this steering wheel is moving. Somebody put a kind of fancy steering wheel in there. Well, wait a minute. Something went wrong, and I'm not passing this. You know, so and a cooler after failure, just replace it. To be honest with you. I'm not sure if you have to replace it, but don't forget the cooler is one of those areas that. You know, if it passes through the cooler and stuff, you know, if you can flush it, absolutely flush that, because you can capture a lot of that in there. But most of the coolers, to be honest with you, they wind up being not too expensive part of it. And I justify in the replacement, listen, hey, your steering gear failed. And to be honest with you, I'm not quite sure if I can get everything out of there. And, you know, do you want this to fail again? And the customer absolutely says no. So, you know, again, it all depends on how you talk. Listen, this thank you thing here, I'm going to leave that on for a bit here. Try to QR code that and try to put in there, you know, go online, and I think there's a survey in there. And I mean, if you don't like it, that's fine too, you know. But that's straight, and this is one of the. It's one of the problems that if it's you're trying to also maintain straightness. This is where you have to find that. I'm looking at that without me seeing, you know, what the truck is, getting my hands on it. But the whole idea of going from end to end and making all your adjustments is that you have that neutral point in there. Okay. I'm gonna get into, you know what, I didn't have time. I might just. That might be a good idea more for my next webinar, Ackerman geometry, setback, because all that stuff, we did the wheels, we did, I don't know, we did a bunch of stuff, suspension, everything, and I think it might be a good way of putting it all together, and then it'll help revisit some of the stuff we did in the last few, and then put the whole alignment concept in place, because you have alignment in trailers you need to do. You got the thrust angles that affect everything. You know, if that's off, you know, you're going to be pushing, and then you're going to wear out time. So I'm going to keep that in mind. You know, that might be a good next webinar, putting it all together. Thank you for doing that. So it's after the fact. And I'm going to knock this off, because I know everybody's going to get back to work, you know. So, guys, I appreciate that. I really, really, truly appreciate you guys coming on all the time, you know. So, you know, hopefully what little bit I was able to do could help. And I'm sure you guys, you know, have the means of, you guys actually work on this stuff. So even if it's a little bit that I was able to bring up that, you know, might make sense. If it doesn't make sense, that's okay, but that's why you have to do your own research too. So thank you again. I'm looking forward to really get a little bit more involved with some nighttime webinars. So thank you, everybody. We're going to knock it off now.